Quantum Physics for Elementary. This video is brought to you by STEM Scholars. This video is an introduction to quantum computing and quantum physics for elementary and middle school students. So what is quantum? When I refer to quantum, what do I refer to? I refer to the very small building blocks of the universe. For example, atoms, photons, ions, and etc. Atoms are the building blocks of anything we can touch, any object. And photons are the building blocks of light. And these quantum objects possess quantum properties which we refer to as quantum mechanics. These properties are unique to quantum objects, which make them quite interesting. The first quantum property is superposition. This is when a quantum object is at two states at once, and as soon as you try to measure or try to understand the value of that quantum object, you instantly disturb it and force it to collapse into one of the values. Here's a GIF that better explains that. As you can see, the skateboarder instantly collapses into one of the values as soon as the eye measures or tries to understand the value. And the value it collapses into is usually random, and there's a probability assigned to it. Here's another experiment. This is Schrödinger's cat experiment, where a cat is put into a box and is put into a superposition. The cat has a 50% of chance of dying or being alive when you open the box. And this is quite interesting because the cat is put into a superposition basically. And there's a 50% chance of it being alive and 50% chance of it dying. Usually in quantum mechanics you can also change the value and probability. For example, it could also have an 80% chance of being alive and 80% chance of dying and collapsing into one of them. Another property is entanglement, and that is when quantum objects are correlated. When we know a property of a quantum object, we instantly know that corresponding property of a different quantum object that's entangled to the original one. Basically, if you measure the property of one, you instantly know the value of the other, which is a very fundamental concept for quantum computing. So what are the applications of quantum physics? Well, quantum physics has been a very interesting topic recently, and there's been a big buzzword that's been gaining attention recently, which is quantum computing. Now, on the left you can see an image of an actual quantum computer with Google's CEO, and you can see it's really big and not portable at all. This is because quantum computers are usually running on trapped ions, trapped atoms, superconducting wires. These things contain quantum objects that possess quantum properties, and quantum computers exploit these properties like superposition and entanglement to do computation. For example, in a normal computer we have bits, zeros and ones. But in classical computers, or in quantum computers, we have qubits, which can be 0 or 1 at the same time. And these kind of properties are exploited in such a way that quantum computers can perform algorithms and calculations that a classical computer would take years to perform. This is what makes quantum computing a very important emerging technology. Did you know that you can simulate quantum computing too? And mind you, I say simulate because you can't actually have a quantum computer, of course. You can simulate quantum computing using IBM's cloud quantum computers, which are available for educational purposes for free online. And there's Qiskit, which is a Python library or a JavaScript library that can be used to simulate quantum computing. It has a built-in simulator, and you can use Python to simulate quantum computing by creating quantum circuits, and it's definitely a great resource. I would recommend you check out both of them. Thanks for watching the video. Here are some additional resources.